Hi, in this video tutorial, I will be talking about Kohler illumination. So Kohler illumination is even illumination of our specimen. So Kohler illumination ensures that the light which is coming from the light source is bathing our specimen with parallel beam of light, and due to that our specimen is equally lighted at every places. This ensures the image quality. If Kohler illumination is not achieved, then the image quality of our microscope could be bad. And due to Kohler illumination, not only our image is enhanced, but also the particular image of the filament of the light bulb used to illuminate the specimen is not found in our image. I repeat, if Kohler illumination is not achieved, then what happens? The image of the light bulb filament that is used for illumination could be focused into the specimen plane. That is why we could get an image of that particular filament. By Kohler illumination, we ensure that we don't get that kind of any optical artifact, and we get even illumination of our specimen. Let's get into details of Kohler illumination and let's see how adjustments are done to achieve Kohler illumination. Before learning Kohler illumination, we have to understand two parts of the microscope. So one part is our field diaphragm. So just look at the light path of the microscope, and field diaphragm is just above the light source of the microscope. If we increase or decrease the field diaphragm, then the amount of light that would illuminate the specimen decrease or increase accordingly. And aperture diaphragm is just above the condenser lens. If we also increase or decrease the width of the aperture diaphragm, then also the light illuminating the specimen would be different. Now let's get back into our microscope alignment. Let's choose a specimen. Let's say we choose a graphene follicle. When we choose the specimen, now you can see there is no specimen or nothing is shown in this particular field of view, and it's almost black. Why is that? Because the microscope alignment is not properly adjusted, and that is why we are seeing this particular type of field of view, black field of view. In order to achieve the Kohler illumination, first what we have to do is we have to fine focus our specimen. Before fine focusing the specimen, we should adjust the condenser. In the X and Y axis, we should adjust the condenser. And now you can see, we can see some portion of our specimen, but it's still blur. So what we can do, we can change our fine focus of the objective and we can bring our specimen into focus. Now you can see our specimen is in focus when we change the fine focus of the objective lens. Then what we would do, we would change the condenser height, and until we get a sharp and crisp edge of this particular image of the diaphragm. So this black image, whatever you seeing side of this particular specimen, is actually the image of the field diaphragm. So this black thing that you can see is actually the image of the field diaphragm. So in our second step of the Kohler illumination, we did adjust the height of our condenser lens so that the image of our field diaphragm is focused onto the plane of our specimen. Then what we would do, we would align the condenser by adjusting it laterally and bring this thing at the center of our field of view. As you can see, it's almost in the center of our field of view. After that, what we would do, we would open our field diaphragm just beyond our field of view. So let's open our field diaphragm. When we open the field diaphragm, you can see more and more light is incoming, and we open the field diaphragm just beyond our field of view, and now you can see our specimen, and it's also focused. And the last step would be to increase or decrease the condenser aperture to manipulate the light that would illuminate our specimen, the intensity of the light that would illuminate our specimen. So as we increase the condenser aperture, more and more light is illuminating the specimen. And after that, what we can do, we can align the filament, because our filament is already defocused. So what we can do, we can focus our filament and increase its light intensity to get better illumination. Now you can see we are getting a better illumination, and this is how we can achieve the Kohler illumination. Let's try it with another specimen. Let's say a fern spore. So here you can see, or let's try with it with biotin crystal. So you can see these are the biotin crystals. First we have to adjust the fine focus of our objective lens. We adjusted the fine focus and we focused the specimen there. And then what we would do, we would change the condenser height, and we would close the field diaphragm first. We would close the field diaphragm as far as possible, but these edges are blurry still because the image of the field diaphragm is not yet on the specimen plane. That is why what we would do, we would change the condenser height until the edges are sharp and crisp. When the edges are sharp and crisp, that means the field diaphragm image is on our specimen plane. Now we would adjust the condenser laterally in X and Y direction and put it in such a way that it is just in the center of the particular alignment. It's almost in the center. And after that, what we would do, we would open the field diaphragm just beyond our field of view. So we opened our field diaphragm just beyond our field of view. Then what we would do, we would increase or decrease the condenser aperture. So with decreasing the condenser aperture, you can see the contrast and resolution is increasing, but the brightness of the image is decreasing. And we can also increase the condenser aperture, and it is actually illuminating. So let's keep it in a way such that there is a sufficient amount of light to illuminate our specimen. And we can also align the filament and keep that thing in focus. We can also rotate the filament, and we can increase or decrease the intensity, and accordingly our image would be done. I hope this video helped you. I hope you enjoyed this video. If you like my video, give it a quick thumbs up and don't forget to subscribe. Thank you.